Good morning. Thank you for joining us for the 19th Annual Acquisition Research Symposium hosted by the Acquisition Research Program at the Naval Postgraduate School. I want to welcome you to panel 19, where we will be discussing Agile practices in software-intensive programs. I'm Jim Day. I'm the Director of Production, Deployment, and Fleet Readiness in Program Executive Office, Integrated Warfare Systems, and I'll be chairing the panel today. I'm joined today by panelists, Dr. Nicholas Wagner from the Institute of Defense Analysis, Dr. William Nichols from Carnegie Mellon University, and Dr. Raymond Madachy from the Naval Postgraduate School. Dr. Nicholas Wagner, has been a research staff member at the Institute for Defense Analysis since 2019. Before joining IDA, Nicholas was a material science and engineering PhD candidate at Northwestern University, where he applied machine learning to the discovery of new electronic materials. While at Northwestern, he was a visiting student at Los Alamos National Laboratory, as well as a research software engineering intern at Google Accelerated Science. His research at IDA includes application of data science techniques to cost estimation and program evaluation. Dr. Nichols is a senior researcher at the Software Engineering Institute with a PhD in physics. This experience includes data acquisition, scientific software development, nuclear engineering, and software project management. While at SEI, he has coached software project management and published research on using software metrics for project and program management. And Dr. Madachy is a professor in the system engineering department at the Naval Postgraduate School. His research interests include system and software cost modeling for total ownership costs, affordability, and trade space analysis, modeling and simulation of systems and software engineering processes, and the DoD acquisition process. He's an author, and his books include Software Process Dynamics. He's a co-author of the Software Cost Estimation with Kokomo 2 model and Software Cost Estimating Metrics for Defense Systems. This is a great panel, for sure. I'll start off with a few words before the panel leads in. But before I do, just a quick housekeeping note. Please use the Q&A box at the bottom of your screen to pose questions for the panelists. We'll answer the questions after the final panelist speaks today. If you have a specific question for a specific panelist, please indicate and we can direct that question accordingly. A little bit about why this panel is interesting to me. IWS is about a year into its transition from waterfall development into the Agile development process. The transition has taught us that, contrary to popular belief, or maybe a surprise or not a surprise to many of you, that we have to think and operate differently. And that includes everything that we do as a PEO, not just in the combat system development area. It's all aspects of the PEO. So it's cultural, it's engineering, it's business operations, everything that we do as we make a transition to the new operating paradigm. We have to go all the way down into the core of the PEO and change what we do. I think you'll get a sense of some of the thought processes that might be required for us to do that through this panel today. In IWS, we're adapting our traditional the traditional V style system engineering process into what I call the system engineering I. And that really, it goes along with the Agile process. Our transition has not been without growing pains, but I can certainly see that the best is yet to come for PEO IWS, and it's an exciting time to be here. And I am looking forward to hearing the presentations today. I'll now turn the floor over to our panelist with Nicholas, then who will turn the floor to William, and finally to Ray. Over to you, Nick.
Hi, one sec. Let me get my presentation started. And let me know if this is now on presentation view.
I hadn't.
Yeah, we good? Okay. Thank you for the introduction, Mr. Day. As he was saying, I'm Nichols Wagner from the Institute for Defense Analyses. I'll be presenting a proposal for some platform infrastructure for agile software estimation. So if you want to get the elevator pitch, essentially, of my talk, this is the research question. How are we going to be able to balance the conflicting preferences of developers who just want to develop software and the people who are charged with overseeing them, and their desire to just have one more TPS report filed for their use in management? And the answer that I'm going to give is automation, and specifically providing automation as like an enterprise solution to software acquisition program teams. Just the sort of core conflict of the research question is, as a developer, you mainly want to stay focused on writing code and developing the software, interacting with your user, getting feedback, following iterative development. You don't want to spend a lot of time dealing with management oversight and other sort of time-consuming tasks. And this has been recognized in some of the reforms that have been achieved lately, specifically if you like the software acquisition pathway. A lot of the reporting requirements that were traditional for software acquisition programs were dropped or modified. And the end result and the goal was to free developers to spend a lot more time doing the coding that they want to do and less time doing reports, which is good. That's how you get to more of an agile development speed. But at the same time, the oversight community has to adapt in some manner because they can't just allow people to develop software on their own and not have any sort of accountability or any sort of information being collected about how to balance competing priorities for funding and other schedule conflicts. The trick, though, is how are they going to get that information in some manner that doesn't really burden the developers? Well, luckily, software development hasn't been going on in a vacuum. In the commercial side, other people develop software, as we know, and they have their own tools and techniques for managing software programs and doing similar things like having a portfolio of projects and tracking their progress and their sort of deliverables. So when it comes to a lot of commercial software development itself, we know there's a lot of tools that are being used increasingly within DoD itself, but have obviously been used outside DoD for a while, like Jira, GitHub, GitLab, et cetera. And these tools are built with integration capabilities in mind for feeding data in and out for other potentially program management software tools or just for reporting and that sort of functionality. We know for things that aren't pure COTS tools that are maybe more sort of custom, like textual documentation, we know that software parsers can be written to handle that sort of information in a way where people don't necessarily need to manually extract structured data from text documents or like say PDF or Word documents that are commonly accompanying software programs. And lastly, we know for things in particular like cost estimation or maybe schedule estimation, things of that sort, we know machine learning is gaining increasing traction and can operate at a speed that is applicable to people doing agile software development. And there's a rich literature of people trying to use machine learning to automate forecasts or generically make predictions from data. So developers and people know these things exist. Why aren't they super common in DoD? Well, one of the big reasons is that every development team on its own is kind of being expected to do these things themselves. And the software acquisition pathway itself, they even call out saying automation as a thing that people should strive for in the reporting, but they don't necessarily say, oh, and if you want to use automation, here are these things you can just download and use to do that. So my thinking is, why don't we provide these capabilities as enterprise solutions to teams, the way some other past examples maybe have functioned? So an example that a lot of people are familiar with that originated out of the Air Force is Platform One, which is a DevSecOps platform enterprise for handling a lot of the boilerplate coding issues that every project was dealing with and still deals with, such as like security, handling a lot of backend hosting needs and other sorts of that thing, connecting to the host to like Cloud One or other cloud platforms. Platform One has been a great success, and you can kind of go on their website these days and see the humongous list of organizations that are developing on their platform and sort of turning out tooling and other things of that sort. But Platform One is a bit limited in this case in that it wasn't really designed for oversight. It was designed purely for the technical development of software. So it's not really exactly what we need here. On the other hand, we have software and systems that are purpose-built for oversight needs, like the CADE office's cost analysis data environment, or CADE. But CADE is not exactly set up for some of the automated workflows and sort of computational access the way Platform One has been. But on the other hand, CADE does have, because it's purpose-built for oversight needs, it has a lot of visualizations that it provides out of the box. It has search functionality, it has like structured data from more traditional software program reports that is of great use to people who are in the oversight community. The question is then maybe how you kind of take the best of both of these and sort of provide them together as a common platform. And this is essentially the kind of the bulk of what my paper was about, proposing just, you know, a hypothetical system that would meet a lot of these needs and to potentially, you know, be given some pithy title like Overlord, just going off of the oversight theme. The potential here, I should say, the bullet point is that a lot of this, because it's kind of built upon ideas from CADE, could potentially be expanded. CADE itself could be potentially expanded, and that may reduce the effort required. But in any case, I'll just kind of walk through the major pieces here. So you can kind of see there's arrows coming in and out of Overlord. I'm imagining this is sort of an architecture diagram of data flows. On the left-hand side, you have kind of the major things that are being collected at the moment from software acquisition programs and how they might interface with this platform here. So at the top left, you would have what I would consider the lowest hanging fruit. So these are like the COTS tools that are being increasingly adopted for software development, like Jira, that already have off-the-shelf APIs that are being used by other commercial firms and things of that sort. My thinking here is, if we are able to create on top of this Overlord platform ingesters for taking in standard metrics from Jira, you know, maybe like the story point burn down rates or other things of that sort that are being considered for collection, have that code written once and supplied to the software development team so that it's sent in an automated fashion, essentially sort of amortize that work over a large pool of software oversight needs. But it's not just data being taken away from the development teams that's being fed into a system. You can also, because it's an API, you can think of feeding data in a rich manner in the other direction, potentially having tooling integrations, building apps on top of some of these COTS tools like Jira, that would offer some, say, functionality that improves with the addition of more and more data in Overlord. So an example might be, as the developer is creating stories and assigning story points to estimate essentially their level of effort that will be required to do this piece of code, Overlord could suggest story point values based upon similar projects that have been fed in the past. So you kind of would achieve over time some harmonization of story point value estimations to different types of work on different teams. And you can imagine other sort of maybe code completion or little sort of automation tricks that can be used to kind of reduce the burden that is placed on developers when they use these tools. In the lower left corner, you have other development team artifacts. So going back to talking about parsing and things of that sort, there's a lot of documents that will inherently not be sort of tracked exactly in COTS tools. My thinking here is on some of like the value assessments or other documents that are much more sort of qualitative. Does the user using their own language to describe how they appreciate the software and what they kind of wish would change. A lot of those documents, even if they are kind of freeform text, have more or less a semi-standard format. And it would also be possible for Overlord to provide us a functionality parsers to take those sort of standard templates and then ingest them as structured data into Overlord, or at least park them in Overlord for later analysis by other people. And it's similar to how CADE now provides some functionality for taking in, say, like standard SRDR reports or, say, flex file things and kind of parsing them out for the user. Now, on the right-hand side, you might have some of the consumers of the data here. So I use oversight or overseers as a very generic term. You might have literally cost estimators, other people like that, or even just, you know, some kind of portfolio manager in some hypothetical budget reform world here. But the important thing is the sort of functionality that's supported now by CADE of searching for data, pulling it out, looking at some quick visualization, showing you kind of maybe like the spend rate or other things, but applicable to Agile. You would also be able to feed in data through APIs. So as oversight users maybe develop their own applications, either outside of Overlord or on top of it, you're able to computationally feed data in live as it changes rather than having a sort of manual updating process. And in addition, like I would say the visualizations, you would have additional visualizations supplied for Agile programs like, story point burn down rates or backlog visualization, things that are just kind of more unique to Agile software development. Unlike maybe some other proposals that you might think of, I don't envision having an entirely new machine learning platform being developed here. My thinking is that you might better to have the sort of data in Overlord be linked via an API sort of connection to some external machine learning model platform that is purpose-built for machine learning, such as like say the Joint Cloud Foundation from the JAIC. But the code and the data itself could be linked in a manner where they both reside within Overlord so that they can be searched through and archived over time, and then linked to the production estimate model over on the machine learning hub or what have you. And the model results fed back to Overlord for storage and fed back to the user as say visualization. So you can kind of see there's sort of this ecosystem that I'm envisioning of data flows going in and out with an emphasis on automation. And the important thing is once that the linkage is built once between say like a tool like Jira for a particular metric or a particular visualization is developed and the code is supplied, that effort is immortalized and kind of reused multiple times. So I'm going to close up really quick. In terms of recommendations for how I think this should kind of be handled, because OUSD ANS owns a software acquisition pathway and are currently receiving data reports from some of their metrics requirements that they've come up with. And CAPE, on the other hand, has been historically collecting a lot of the software program management data and is still being supplied with traditional SRD reports for certain projects. It's logical to me that they should collaborate in building any sort of new platform that seeks to kind of solve this issue for both parties. In conjunction with services, of course. In terms of who might build it, I'm aware that there's a CAPE analysis data tools Tiger team where a lot of the talent that you would expect that you would need to build this sort of solution, the software engineering and the sort of subject matter expertise of say cost data and software program data could be located there as a potential place to start. And lastly, the program itself, I highly recommend not following a waterfall method of development and instead being a little bit meta and following the software acquisition pathway itself to develop this system. I think the cost acquisition community would be great I should say the cost estimation community and the program management community, oversight community would be great, happy to act as end users and sort of do this iterative development to build the solution out, delivering value from day one. All right. So that is my talk. Thank you for your time. I will now transition it over to Dr. Nichols. He will present on his paper.
Well, thank you very much. Get the share going. Okay, I think you'll see some overlap with what I'm going to talk about and what you just heard from Nicholas. I'm going to be approaching it from a different point of view, though. We are looking at automating the collection of data from the DevSecOps pipeline for the purposes of program management. That is, we want to be able to apply program controls, program management at the speed of relevance. Now, why is this an issue? In the modern software development world, things are moving very quickly, especially with Agile and DevSecOps. We're constantly getting product out there. But from a programmatic standpoint, what do you see from a standpoint of insight? You might recognize these reports that they're going to get. Typically, these are in the form of things like seed rules. And if you've ever gone through a seed rule, you know that these things are going to be coming out with some lack of frequency, and they're going to be 4 to 6 weeks late if you're lucky. So as the projects are racing ahead, the program insight is still lagging behind. So you're left with this underlying problem of how do you control a project that is running faster than your information flow? Now, theoretically, DevSecOps provides constant opportunities for collecting information and data. But controlling a program is different from a single pipeline. Yeah, projects monitor their work differently, but what does a program see versus what does a project see? And I'll get into some of the other idiosyncrasies with respect to differences among projects that constitute a program in a bit. Rather than just having a single research question, there are actually a number of questions that present themselves. The first is from the program standpoint, from a DoD program manager in this fast-moving environment, what are the information gaps that you're facing today? What information do you need? What are your actual information needs for prediction and for actionable programmatic decisions? Once you get that, now you can start to think about what data can we actually get from the pipeline or other sources that's going to answer these information needs. Now, you want to also understand, how does the programmatic information differ from what you're going to see being used for pipeline management? Just because they are collecting a lot of information doesn't mean it's going to give me, the program manager, relevant information. What can we do to gather and analyze the data that support real-time or almost daily programmatic decisions? One of the ways you could think about this is, instead of relying on procedural reports, you could potentially go for the insight rather than the oversight approach, and just have those embedded programmatic representatives look at the same data that they're using to manage the projects. You want that data available instantly, constantly, and you want to be able to use that data to make projections. Now, one of the things that we've come across is the question of, how do you take that raw data? There's lots of raw data, and if you look at the actual information that is being output from the tools in the DevSecOps tool chain, or is we've got to do some work to transform and join and label that data to retain context and put it together. How must this be done? And finally, how do you present the final results of this information to decision makers? Lots and lots of questions, very practical. To approach this problem, we first identified a set of subject matter experts with some expertise in large DoD programs. So we tried to get people who had had a record of success, wanted to see best practices, get insight into how they address the problems. These subject matter experts also, by the way, are going to be used to help review our results. With this in mind, we established a ConOps, a framework, if you will, and validated some key scenarios that we thought were relevant to the program management. From this, we constructed a prototype pipeline. We're working with a couple of large customers right now, and we're using similar pipeline construction to those which should be used on some DoD programs. This pipeline is a prototype for modeling, but we are going to be using something essentially similar with these customers in the not too distant future. We hypothesized some program management indicators for these scenarios, and then we did some modeling for the data collection. So what we did in our first year of this program was we did some modeling to generate synthetic data. That is, we wanted to verify that if we had a known quantity of a simulated project, the data that would be generated at the different points could actually be collected and assembled and provide meaningful insights. We built the indicators, we performed the analysis. This was essentially an integration test, a proof of principle, if you will. Now, along with that, we finally validated these initial results with our quarterly review panel, and I'll show you in a bit what we were showing them. First, let's start with the ConOps. If you're dealing with a program, and this is a highly simplified program to be sure, but we're dealing with a program where you're going to have something like an MVP, you might have a minimum viable capability release, you might have a sequence of releases. These are all going to be staged in the roadmap. There should be some representation in a work breakdown structure. They're going to be decomposed into epics, work packages. They're going to be sequenced, and you should have some estimates. Now, it's important here that there be some estimates at the high level if you want to do tracking. But you have to make sure all of this is in place before you actually get into the DevSecOps pipeline. Now, the DevSecOps pipeline has the virtue that it is well defined. There are a number of different ways of building pipelines, a number of different tools that can be used, but once you have an instantiation, you have a very specific sequence that will go through the nominal paths and the exception paths. And you're typically going to have stages like a code commit with a repository. You're going to have unit testing, integration and build testing. You might have static analysis. You're going to have some kind of staging pre-deployment, various types of tests, and finally, you're going to have deployment into production. This is actually, every one of these steps gives you opportunities to measure different things. For example, the most simple thing to measure in these cases would be something like a timestamp. When did an event occur? Other types of data are potentially available, however. Things like unit tests have pass, fail. Code commits are going to have all sorts of information on the actual code, the modules, and so forth. Now, as we go through the development and we start collecting these events, now we have to arrange the information. We have to take this raw data and do various sorts of transformation and joining prior to storage. Because if we can't store this data, it's not going to be available for the long haul. And trust me, you don't want a raw dump of all of these different CSV files that are coming from a DevSecOps pipeline. You're going to have to do some transformations. And indeed, you have to collect some of the context. For example, what was the actual pipeline that they were using? Don't assume that you're going to be able to infer this after the fact. Finally, you want to actually be modeling. So you have to have some infrastructure around a data storage system. You want to have some visualization tools and engines. You want to have trip points. You want to have various types of analyses. One of the dreams that we would have would be to provide good data, automatically collected data for folks like Ray Madachy, who will be speaking later. He's done some wonderful things, and the ability to get actual data collected automatically is really our holy grail. So to keep the initial work straightforward, we focused only on a couple of scenarios. Basically, we wanted to see, can we track progress and make projections to complete? Okay, it sounds fairly simple. There are a lot of complications that actually come up, but we want to look at things like, how are we doing against the estimates for these components? Are they bigger or smaller? Are we actually getting the effort we expected? Which items actually compose the necessary capability? And for a capability, what is the actual burn up % complete toward that capability? What's the variation? If you know the variation, you should be able to make some projections. Now, second to that is, if your projections are showing you're not going to meet your objectives, what are you going to do about it? Now, this is one of the places where it's very important in the DoD to get a heads up if you are not on track. It's all nice and good to talk about descoping, but in my experience, I used to work for the nuclear Navy. The ship had to sail. If you're working with NASA, you have to launch that satellite, and you might not get another launch window soon. If you're in the Air Force, you may have to take an aircraft out of service in order to do flight testing. Or if you're in the Army, you might have to reserve an artillery range. You really need to know in advance if your capability schedule is at risk. So you need to know if you make certain adjustments, if you make certain changes in the capabilities required, or if you make changes in the resources available, move teams around, what are the effects going to be? We did a detailed model of our pipeline. This is a sequence diagram that essentially shows going through different tool stages. And we have here, you might recognize continuous integration through a GitLab, a continuous deployment managed by GitLab, or a Prometheus doing a lot of the metrics aggregation. Any number of tools could be involved here. The specific tools aren't so important as understanding what the tools are, in what sequences they're going to be operating, and what the different paths through this trace are going to be. This is something that we built into our initial database model so that for any given pipeline, we understood what the normal and exceptional paths would be so that we could interpret the data as it came through. So essentially, we modeled this pipeline and we generated synthetic data to provide us information on tracking the % complete and making projections. So with that, I'll show you a couple of quick examples. What we did was we simulated an entire project. using Monte Carlo. And then we used 10% of the data to make projections. From this point, based on the bias that we saw through 10% and the variation we saw in the completion rates, we generated a set of Monte Carlo projections and computed a likely range of potential completion dates. This was essentially a 90% completion interval here. Now, the nice thing is, as you continue to gather data, you can rerun these calculations from any of these points, and you can see how these projections change over time. Now, we did another projection based on making some assumptions on changing the resources. In this case, we did a very simple one where we doubled the resource. We basically gave them twice the teams available to do the work. And with that, we see this inflection in the completion, and we were able to bring the dates in and get a narrower projection difference. So this was really developed essentially as a proof of principle for the data collection. What we're working on now is implementing this in a real project to try this out live. Now, quick summary. We found that pipeline data does not speak for itself. That is, you need a lot of additional information. You need to have connections between the pipeline and a lot of the pipeline management software, which is not necessarily there. In particular, you have to have the kind of labeling and information so that you can map the capabilities to your roadmap to the work actually flowing through the pipeline at any given time. And that is not a given. So we found that's one of the things that we're going to have to specify as they move forward. A lot of open questions on how you make sure the data is consistent and interpretable. We do have a proof of concept that the automation has promise. We are looking at potential extensions, which I'll talk about in a minute. We also have a starter set of management issues supporting these DevSecOps measures. That is, we have a starter set of these issues, and ongoing, we want to build up an increased set of practical questions that the programs need to answer. That is, we want to tailor the data collection and storage process so that the data that the developers are using to manage the project can be reused, but perhaps organized differently to answer the programmatic questions. Now, we've also demonstrated the capability of doing some basic data storage, transformation, and data relationships, along with a lot of the assumptions that go into that. Now, in the future, right now, we are beginning to look at the problem of multiple interacting pipelines. That is, you have multiple pipelines in a software factory. Each pipeline has its own personality. By personality, I mean they've got different people. They're going to be working at different rates. They're going to have different biases in the estimation, different work rates. They're going to be interacting at different times. You need mechanisms for pulling these together into a coherent picture. We're looking at extending the types of questions that we can ask. One of the things that keeps coming up among our customers are, how do we do CATO? That is, how do we deal with the need to have ongoing assurance for security so that we have continuous authority to operate. Along the way, we want to make sure the data is stored in a way that it can be later reused for machine learning, AI, predictive, and causal analytics. This requires very precise definitions of the data, or the data simply won't be very useful for these purposes. And finally, we are continuing to innovate new displays, move beyond the simple timelines, the simple run charts that are typically being produced with the tools today, such as Prometheus. A lot of the basic information is there, but we want to find new and innovative ways of using that information to support the program needs. And along with that, we're constantly looking for input for both our review panel, input on the programmatic side, and potentially collaborators who want to start using some of the techniques we're looking at. And with that, I will turn this over to Dr. Madachy.
All right, great. Very interesting, Bill. we'll sign up as be one of your collaborators. We'd love to have a measurement system like that. And I can see what our next thrust is going to be, try to estimate DevSecOps projects as well. But let me just talk about Agile for now. We can't keep up with everything. Okay, so here's our work on new effort and schedule estimation models for Agile processes in the DoD. We need to adapt to these. We know they are rampant and being adopted all across DoD. And so we're familiar with the new acquisition pathway for rapid development, right? It prioritizes speed of delivery. We've got to get systems out there very fast as possible. So Agile processes are advocated in the DoD. And so these things are happening. Projects are being completed. And I'm sorry, I just realized my video was off. Excuse me, people. I am here live. Okay. And so projects are being implemented and systems are in the field being used by the war fighters. And so how can we better adapt to this acquisition? Because if in Agile, they only plan ahead for 2-week sprints, the contractors, when they actually implement, how can we deal with this in acquisition? And so here are our recent results here to help estimate cost and schedule of Agile projects very early in acquisition when we have relatively little knowledge, but we will make use of the available data we have. So I'm just one of a team here, myself and my colleagues Wilson Rosa and Brad Clark. We've been working together for years here, analyzing DoD data by domain, segmenting by domain and operating environments, develop CERs. And now we're segmenting by process, Agile versus traditional processes. Okay, so if Agile processes work, what's the problem? Well, it's always the chicken and egg early in life cycle, right? What can we pin our estimates on for proposals and budgeting that we need here early on to evaluate the contract proposals and establish the budgets that we need here on the government side? And so given that we just hand off requirements, initial set of requirements, but when they get down to the actual sprints on projects, they use story points or epics, to plan the 2-week sprints, but that's not practical for early estimation. We don't know this until much later during the project. So here we'll show you some resulting effort and schedule models using something we can pin our estimates on early in life cycle based on projects in the CADE here. So these are most recent projects as of when we wrote our paper, which came out last year, as you see. And so the bottom line is that we see that if we just count the initial software requirements, that's very effective itself to estimate effort and schedule of these Agile projects. And we get even better accuracy when we add the application domain and peak staff, which are also required inputs. So of note here, we collected this data here, and Scrum is a predominant Agile process reported across all. Like on the order about 90% of the data points are Scrum, what the version of Agile. Okay, so we've been working on these for years here, looking at the repository of DoD data. We get the data records, we have to filter them, and we segment the data across domains and operating environments because those are important sources of cost variance. We see those effects, and so those are important descriptors for calibration, and now by software processes to develop the best CERs and SERs available from the available data. And so the research questions are, given the cost factors that are available, how effective are they? So this is using available data. On the other side of the coin is that, we often, well, obviously we always see downfalls or gaps that we ought to have better data, more consistent, or something standardized somehow. And so in the past, we have made recommendations to improve the CERTA report to the CAG. And fortunately, those were implemented, which enable us to do this research here, because now we have captured the domain and process type and other reuse data, which wasn't available in the CERTA before. So it's continuous process improvement with this data form, which is the source of everything that we did a calibration against the CERTA. So this is software resource data report. It's the standardized mechanism. It's required in the DoD, and it's clearly quantifiable, objective, measurable data. It's required for all large projects. And now we have fields here for what type of processes are being used. And so there's a set of reports here in the beginning, at every delivery, and the final report. So this SERDR here contains, size and schedule and technical characteristics. In the beginning here, the developer has to provide a count of the functional requirements, external interfaces, and peak staff. So these are what we are going to consider here for model input variables as we develop the CERs to see how well they perform from the initial report. After a project is completed, they have to submit a final developer report, which provides the actual effort, schedule, and the process being used here. So for developing our CERs here, these are the output variables, the actual effort schedule to calibrate against. And so this is provided contract end. This is submitted at the contract award. So here's the flow of the data. The government defines the baseline requirements in the SRS before contract award, and the interface requirements in the IRS. And these are used by the contractors in their proposals. And when they get the job, they write their initial developer report here based on these counts here of the requirements for interfaces and functional requirements. So these are, why should we use these? Well, they're simple to count. They're required, always available no matter what kind of process you used, Agile or waterfall, traditional. And of course, everybody should have an enumeration of their requirements. And it's required on DoD projects. And so we count these in total here. A sum is initial software requirements. This is our baseline size measure for these CERs and SERs. So I'm not showing you all our iterations here of developing the best fit CERs here. We explored models with increasing numbers of cost factors and fidelity. First, we looked at requirements only, which looked really strong of itself, single variable CER. Then we added domain, the application type, for example, automated information system, engineering system, or real-time embedded. Those are examples of the super domain. And then we added now peak staff, which is required to be reported at the beginning of a project. And so those are the three input variables here. And let's see how it plays out. Really strong here. Here's the formula to estimate the number of person hours for the Agile project in total, using the number of requirements, the peak staff, and then simply a selection of the domain, which is just a calibration factor there. 3.3, 3.7, 3.9. And it looks particularly strong. Look at this, just R square 87%. Wow, that's tremendous. Small MMRE. You see here that the residuals here are straight line, looks like a good model here in our logarithmic space. And real happy with the other statistics down here. So pretty accurate, low p values, and the variance inflation factor looks good here. Okay, so really useful here. We can use this for various different ways here to cross-check cost proposals. And developers can use this themselves here to do a sanity check. And after contract award, we can use this with actual cost data and see how it plays out after contract award. So here's a schedule model of the same three input variables for number of requirements, the peak staff that's reported, and the domain. It looks pretty strong as well here. 70% adjusted R-squared correlation and gives the statistics again. And so all of these, when we added two variables, both effort and schedule improved. That is when we added peak staff and also the domain. Each time effort and schedule improve here by adding another successive variable. So this is enough right now, only 3 input variables, and we have some pretty strong relationships here. Happy with the fidelity. That's interesting. Remember, that's only just using the initial software requirements. So here we're just stepping through the manual calculations for a real project, for a radar display manager. Here's all you need here. This is something that's enumerated and listed on the SERDR. and the requirements as well, peak staffing and the domain, and just plug and chug here. We can see this number of hours, schedule time, and average load per month. So we're trying to make some tools here that people can use. We don't want to go through laborious manual calculations all the time. Here's a tool that we've just started here at this URL. It's clearly what you see here is bare bones and incomplete, but it is working as such here with this small subset of input factors. And so all the bells and whistles are going to be added here, and other utilities such as reading certain Excel files to automatically populate the cost model, extract the size data and other cost factors. That's where we're going with that. And check back again later here at this URL for improvements to this tool. Okay, so it's really interesting here that if you use initial requirements, which is some of the functional and external interface, we have a very effective sizing measure for early estimation of effort and schedule. Despite all the requirements of volatility that happens on programs throughout the life cycle, we can conveniently use the initial software requirements. Very handy and convenient. And the accuracy improves when we add application domain and peak staff. And we can use this in different ways here. If you're government, you use it to cross-check proposals. And developer, you can check your proposal as well here. And it'd be nice here if the contractors could add peak staff along with their requirements with the domain here to do their estimates on proposals. So if contractors could match this on their side, we could have a common objective model used among us. And that's where we are on that. And we are continuing to pour over the more recent data here. And we want stuff on DevSecOps. All right, so that's the end of mine. Thank you very much.
Awesome. Thank you, guys. Thank each of you for your great presentations. I'd like to open up the Q&A at this time. And just a reminder to please use the Q&A box up at the top. I see we have a few questions coming in right now. So why don't I just go right to those? Okay. Can you give an example of a functional requirement? Are there standards of what qualifies as a functional requirement? Asking to better understand how counting requirements can vary across DoD and various application domains. I think that question goes to Ray.
A functional requirement whereby a typical project might have on the order of maybe 100 or a couple hundred requirements, like the radar shall be able to track planes with a particular accuracy, for example. It's a short testable requirement at the software requirement level, as opposed to an interface requirement, which means thou shalt be able to support, a comm link with some other system or sensor or something like that. So a requirement for the interface versus a functional requirement on what the system needs to perform.
All right. This question is from Richard Halliger. What if contractors, suppliers had the real models available? Would them tailoring their RFQ, especially team size, documents to exactly meet the model to win the contract be an issue for measurement?
Well, if they're playing games, you mean to meet some bogey? Well, that's the same old games as before, right? So we just need to evaluate our range of uncertainty and see where that lies. If that's their behavior, well, they can always try to play games, but I don't understand any better. Can't stop that behavior, right?
If I may, I would also add that this is one of the reasons why having live models, like say based on machine learning or something else, matters a lot, and having visualizations of their performance over time. So being able to detect the drift as the model becomes less accurate as people start gaming it is something that would be enabled by having some kind of live system where models like Ray's could live and be continuously updated.
Right. And folks, if you have follow-on questions, please just add them in, and we can keep them going here. Okay, this one is from Christina Coffin. You discussed Seadrills and program controls. Are you referring to EVM? That's question one. Do you see EVM on Agile programs? Are there any sources available about successfully applying or analyzing EVM to Agile programs? And I'll open that question to the panel.
I'll take a first stab at it. Seadrills include, but aren't limited to EVM. There are any number of pieces of information that could turn up in a Seadrill. And you certainly can use EVM on Agile projects. It's really just a percent complete. If you are building something incrementally, that should be relatively low-hanging fruit. There are examples of being applied, but it still has to be applied with some caution, with an understanding of what you're actually trying to do with EVM. One of the sources I go to are some NDIA presentations from, say, Glenn Alleman. I'd highly recommend looking at those. But again, EVM gets a bad reputation, but I think that's more from misuse than anything intrinsic to EVM. Any
other thoughts?
I would just add, as an outsider who hasn't done software development in DoD much, I just had never heard of EVM before I started working in DoD, and somehow commercial software is still developed and they still deliver projects that have value. So I think outside in the commercial sector, it's just not a concept that is very commonly applied, at least in like the environments that I worked in. So I don't know, take that anecdata for how you will.
Well, Nick, you mentioned that. Can you maybe elaborate on some of what commercial industry does to perhaps measure performance, or get to an estimate of complete? So
my only sort of context here is really going to be Google. That's kind of like, and they have a very particular way of sort of handling some of this information. The way that I would think about it is there's essentially a culture of abundance of metrics. They've reduced the cost to collect data to so low that they might as well just keep everything on everyone and then use some kind of statistical learning or some other, analyst sort of subject matter expertise to tease out what actually matters as a signal. And then they'll be tracking tons of different things that are relevant to their business. So of course, money is the obvious one from advertising. But when it comes to other products that aren't directly money making, like say search, they have all kinds of metrics on, how likely is someone to click on the top link, how likely are they to come back, how long do they spend on the site, what browsers are they using, what country are they coming from. They basically measure everything. And then they correlate a lot of that with, I guess, ultimately now more the business side. But in the old days, just generically, they have metrics that matter for their sort of business value. And they just analyze things as they see fit and necessary. And they just continuously kind of refine what they collect and how they use it.
It's more like,
yeah, I do have a bit of a response to that. And one of the things you do see is a distinct difference in the needs of commercial industry, especially web-based types of producers versus the DoD. And where you have industries that are, for example, tightly schedule bound, for example, tax software, or highly capital bound. We worked with a company that did very expensive blood analysis machines. You really do have a need to know if you're going to be able to hit a date, and you have to make accurate cost projections. It's not. This is the sort of thing, if you're building, say, a computer or an operating system, you have to be able to make some reasonable projections. Although we do seem to be getting into a world where we'll just take what they give us.
Yeah, and I will say I wasn't a PM at Google, so that I wasn't as familiar with some of that. A lot of that information was collected. Like I know, at least for developers, they would collect some of the software sizing metrics that people talk about. So like your commit frequency and like the lengths of code you would submit. A lot of that was just tracked automatically. And you just kind of for fun would look at other people's sort of profiles and kind of see how fast that line was trending up or down or whatever it may be. I'm sure on the PM side, they collect a lot of information as well related to schedule and things, because it's not like they just throw money and burn it in a hole in the ground. There is some discipline.
No, but again, there's a distinction between being able to constantly put out product that's immediately marketable versus the kinds of things where you've got to deliver, say, an aircraft. It's a very different world. It comes, it's most stark in something like, say, NASA work. If you're doing something in NASA, you better be able to hit that launch window for Mars.
Yeah, that is true.
Yeah.
So they have external constraints.
Exactly,
Yeah.
and we had the similar issues when I worked for the Navy. The ship, the submarine had to launch. You had some hard dates. They had a lot of money tied up in preparing crews, the captains, the all sorts of hardware. You just had to be ready. You have to
Thank you,
juggle a
William.
lot of things.
You just described my job, William. Thanks. Awesome. Hey, Ray, do you have anything you want to add on the EVM question?
Well, I know they do use EVM on Agile projects. Might be kind of tough, but I know it is happening. Yeah.
Awesome. And I see, Dr. Nichols, you answered the question. I'm gonna answer it out, or ask the question out loud anyway. Are there, and this is from Victor Gonzalez, are there any case studies or templates on your presentation available to DoD programs? Need to copy from the best and make up the rest. I like that. Rip off, deploy.
Well, the honest truth is we're just about a year into this research program, so we don't have a lot ready yet. We are right now in the process of trying to put together some of the materials where we can do more outreach to DoD programs.
All right.
It's a work in progress.
Okay. Any other questions from the crowd? I'll ask one just while folks are maybe thinking about a few others. Again, this question will go out to all of you. We talked a lot about what I would probably are maybe little tweaks to how we would traditionally do program management in the Department of Defense. What do you think are the largest cultural barriers to implementing some of the methods in the papers that you presented today? I'll start with you, Ray.
Well, people have been doing their jobs for a long time and used to the old ways. Just a culture of socialization, I'd say, is one thing. Right? Are the staff agreeable to these new things, and are they going to adopt them? Right, and that's part of it.
All right, William, any thoughts?
Yeah, a colleague of mine observed a bit wryly that the reason software measurement is so bad in software engineering is because software developers don't want to be measured. And there's more than a little truth in that, in no small part because the measures of software developers have been misused for so long. So part of the big cultural barrier is getting an environment of trust where you're going to be using the measurements appropriately and non-threateningly.
At my end, yeah, I would say there's that culture of, you want to have the culture of collecting a lot of information and experimenting with what's useful and using it in an appropriate way. I would also say the other thing is the sort of incentives for different groups of people. Often they're sort of narrowly focused on their own issues. And when it comes to like enterprise things, they're told it's nice to kind of do some of these things, and they kind of understand that there may be a better way out there, but they themselves aren't rewarded for necessarily trying something new and potentially failing with it. And they're certainly not rewarded for doing a bunch of effort so that someone else benefits across the rest of the teams. That's kind of my 2 cents.
Okay. All right. This question is for Dr. Wagner. And I think you're very well suited to answer this. So you presented the topic of overlord, or the concept of overlord. What is used on the commercial industry side, and how is it used? And if not, why not?
In terms of like tooling and things, well, I know in terms of
thinking in the overlord sense.
I will say most organizations don't have that sophisticated. It depends, I guess, really depends on the company size and like Dr. Nichols is getting at, how responsible they have to be with their program management. I know like generically across a lot of teams, Jira is probably the #1 sort of market leader when it comes to software agile project management. I don't necessarily know if that's the best tool out there. It just has a huge market share. And And again, I'm not a PM, but a lot of the sort of things we're talking about, visualizing schedule, how well progress is going, how much funding is remaining, a lot of those visualizations are standard, say, Jira products and other sort of project management tooling out there. I mean, there's like Asana, there's a million other competing project management tools. We'll do a lot of this sort of reporting by default. It really depends on kind of the shop you go to, what they sort of are kind of using. I would just say that generically, there's a lot of competition, a lot of experimentation, and definitely a big focus on a combination of quantitative measures and then like some of the more soft skills that PMs are known for.
Okay, awesome. For Dr. Nichols, thinking in metrics and as program managers start thinking of using agile methodologies, what are the most relevant metrics that a transitioning program should think about, and why would you think that?
Well, I think the places we're looking at right now are going to be issues not just of productivity, but of consistency. That is, are you able to produce at a rate comparable to what you are projecting? That is, can you predictably hit schedules? Unless you can predictably produce output, nothing else really matters from a programmatic standpoint. But once you have that ability, now you can start to worry about some of the real important things. And that's why we're thinking about not just the security aspects like Cato, but all of the quality management, which is why the Japanese took over the automotive world a couple decades ago.
Understood. All right. I think those are my questions that I have for the panel. Are there any further questions from the audience? All right, Victor, are there any initiatives to include the contracting force in the Agile software acquisition pathway? The current contracting members don't really understand the adaptive acquisition pathway. I can tell you what we're doing here in IWS on that one, Victor, and then I'll turn it over to the panel to maybe help out there. But we're integrating our contracts team into just about everything we do. As we begin to do development in our Forge outpost, we have our NAVC O2 contracting representatives that are resident in Forge and aligned to us. So I think there are definite approaches that programs can and should be taking to integrate the contracts team into using that adaptive acquisition pathway, or the OTA, so to speak, right? We can't do it without having contracts alongside. So I'm just going to tie back to my comment earlier in the discussion. We are changing. When you make this methodology or transformation, it's everything that you have done or have done in the past. You have to start in thinking differently about who your business partner is and how you manage your business, manage your interaction with your business partner. But yes, there are for IWS, there's absolutely initiatives to bring the contracting force along with us. And over to the panel for any further insights.
I don't know if you are familiar with practical software measurement, but I don't know that it rises to the level of these initiatives, but that's a group that includes both industry leaders and government folks familiar with implementing the adaptive acquisition pathway and defining the appropriate types of measures. So if you do a search on practical software measurement, you'll find the results and the outputs of that group, and that's ongoing right now.
Yeah, I'll add to what Bill said is what they are working on is called the Digital Engineering Measurement Framework. And the version 1.0 is coming out here very soon. And that has examples of digital engineering, which is related to DevSecOps, if you can measure all your artifacts in your tool set. And so, yeah, PSM is put that together as aligned with NCOSI and IEEE and some others.
Yes, and NDIA, and last year
Yeah,
they
right, of
published
course.
last year they published the I think it was 2-3 parts for continuous development, continuous integration, continuous development.
I was going to say so much, I put it in the chat. I was going to say, personally, I'm not aware, but whenever I have a question like this, I just email Sean Brady and ask, hey, is the software acquisition pathway doing this thing? And he usually is pretty helpful at just telling me yes or no, there's a community of interest or not. And usually there, for pretty much any community of interest that you would think of, there generally is some mailing list with people talking about stuff. So.
Yeah, I think it's a total system transformation, though. I think it's really from our experience here in IWS. It's everything from our financial team and our contracts team and the engineering. Everybody really has to think it's a big change. You have to think differently. You have to communicate across all entities and stakeholders. So I hope that was helpful to you, Victor. All right, I don't see any further questions coming in. Up, and Victor said yes, thank you. So awesome. All right, I think that would wrap up the session for us. I want to thank each panelist for their time and efforts and for providing these briefs and spending the time to write the papers, and the extended teams that helped out on each of those papers. Great conversations. It has been a great conversation today, and as I said in the beginning, I think this panel is important as organizations begin to move into a more agile development methodology and process. So with that, I will turn my camera off and wish you all a wonderful day and a wonderful weekend.